Hello again, my friends. In this video, we are going to study the lot sizing heuristic with the periodic order quantity. The idea of the periodic order quantity is to change the order quantity whenever we need to release an order, okay? Whenever we observe a net requirement, obviously we need to release an order there, or we need to plan a order receipt. Now, that quantity that we are going to determine is going to be variable this time. It is going to change depending on the situation that we have. But we are going to make this decision based on a period, okay? So in this problem, we are going to determine the periodic order quantity interval. Okay, it is basically an integer value, which will be the number of periods that we are going to consider when we release or plan the receipt of an order. Okay, so that is going to be an integer. So let's just say 4. This means if the periodic order quantity interval is equal to 4, whenever we have a net requirement or whenever we need to plan an order receipt, we are going to consider the net requirement of that period and the demands of the following 3 periods. So because the periodic order quantity interval is equal to 4, we need to consider the total requirement of the next 4 periods when we are determining our order quantity. But in order to do that, first we need to determine the periodic order quantity interval. Now, the method will start just like the economic order quantity approach starts. So remember, when we are making a lot sizing decision based on the economic order quantity heuristic, we first determine the average demand per period, and based on this average demand, we determine the economic order quantity. Now, up to this point, these two heuristics are the same. But here, instead of using the economic order quantity, we again divide that economic order quantity to the average demand rate. Now, remember, in the basic economic order quantity model, when you divide the economic order quantity to the demand rate, you calculate the order cycle of the problem, which is the time between, or time that is supposed to be between two consecutive orders, okay? So here, tau star, again formulated as the ratio between the economic order quantity and the average demand, is going to define our periodic order quantity interval, okay? Obviously, that result may not be an integer because the order quantity is usually rational and the average demand per week is also rational. When you divide these two values, obviously, you are going to end up with a rational number again. So what you are going to do is, since the periodic order quantity interval should be an integer for this planning problem, which is basically iterated over discretized periods. So periodic order quantity must be an integer as well. You round this value to the closest integer, closest positive integer, okay? However, here's the thing. I mean, especially I say closest positive integer because depending on the nature of your problem, this tau star value can be somewhere between 0 and 1. And if it is close to 0, that does not mean that the periodic order quantity interval should be 0. So please do not forget, if you get a rational number in the end of this calculation, you round it to the closest positive integer. Okay? Now, the order quantity that we are going to calculate is going to cover the net requirement of the following next tau star periods, okay, where tau star is an integer now. So this means whenever a net requirement occurs, we are just going to consider the following next tau star periods. And depending on the demand amounts in the next tau star periods, the order quantity is going to be variable. Okay, it is going to change. Now let's see how we can apply this idea to the same problem. Again, please go back to the video related to load sizing with load for load approach, if you do not remember this question. Now, let's perform the problem. Again, we determine the economic order quantity as usual. So the average demand per week is equal to 27. And the economic order quantity, when the fixed ordering cost and the unit inventory carrying cost is plugged in, is equal to 73.48, which is approximated as 73 units. Now, you may not approximate this, but it is not going to make a big difference, my friends, I guess. So in the next formulation, without rounding the 73 units, you can directly use 73.48 to get more accurate result. But I mean, for this instance, for this problem, it is not going to make any big difference. And for general problems, it is not going to make a big difference either. So as you can see, when we divide the economic order quantity to the average demand per week, 73 divided by 27, or 73.48 divided by 27, you are just going to get a value somewhere between 2 and 3. That value is going to be closer to 3, obviously. If you use 73.48, it is even going to be closer. So you should round this value to the closest integer, and that is the result, 3 weeks. Okay. Now, if you ask me this question, I mean, what if this value is 2.5? Should we choose a 2 or 3? I mean, it doesn't matter at that point. I mean, if there is a tie, you can just solve it in any way you like, because I mean, this is a heuristic after all. But I mean, this kind of things do not happen so frequently. Okay, that value obviously going to be closer to one of the neighboring integers compared to the other one. Now, but if you ask me this question, should we use a rounded economic order quantity here or the unrounded one? I recommend you to use the unrounded one here, the original economic order quantity that you have calculated in the square root. But as I have told you, still it would produce almost the same value. Now, that means what? This periodic order quantity interval is estimated as an integer value of 3 weeks. So whenever we observe a net requirements, whenever we need to plan an order receipt, we are going to consider the following 3 weeks net requirements, okay? The net requirement of this week and the requirements of the following 2 weeks, the demands of the following 2 weeks. So this means we are going to consider the net requirements of the following 3 weeks, and we are going to plan an order receipt, which is going to be equal to the summation of the net requirement of the following 3 weeks. But we are going to do that whenever we have a net requirement, my friends, okay? So let's see, again, the on-hand inventory that we have in the beginning of the planning horizon meets the demand of the first period. So a net requirement will be observed in the second week as 30 units. Now, we need to plan an order receipt at this point. But when we are planning this order receipt, we are going to consider the following 3-week periods demand. So we have a net requirement of 30 units here, plus 40 units in the third week, and plus 0 units in the fourth week. So for the following 3 weeks, the total net requirement is equal to 70 units. Therefore, we plan an order receipt of 70 units. Now, that will meet the demand of, or the net requirement of the second week, and we will be carrying 40 units of inventory to the next week, which will meet the demand of the third week, obviously, and we will carry nothing to the next week. Then, in the fifth week, there will be a demand, and that whole demand will be our net requirement in the fifth week, because there is no inventory carried from the previous periods. Now, at this point, we need to plan another order receipt, but that quantity will be different from 70 this time. Why? Because at this point, the net requirement, the total net requirement in the following 3 weeks will be 10 plus 40 here, plus 30. So we need to plan an order receipt of 80 units. It will meet the net requirement of the fifth week, and 70 units will be carried to the sixth week. And It will meet the demand of the 6th week. 30 units will be carried to the next week, and it will meet the demand of the 7th week. Okay. Now we move to the next week, but next week there is no net requirement. Okay. So this means the first net requirement this time will be observed in the 9th week. Okay. And which is obviously 30 units. And we will be planning an order receipt at this point. Now, again, we need to consider the total net requirement in the following 3 weeks, as our periodic order quantity interval is equal to 3 weeks. So the net requirement here is 30 units, plus we have a 55 units of demand in the next week. And since this is the end of our planning horizon, we cannot make any further calculation. So the total net requirement in the following periodic order quantity interval is 85. We plan an order receipt of 85 units of inventory here, which will meet the demand of, or the net requirement of this 9th week. 55 remaining units will be carried to the next week, which will meet the exact demand of the 10th week. And we will not be carrying any inventory in this plan to the next planning horizon. Now, you see, even if the periodic order quantity interval is 3 weeks, the time between consecutive order receipts are not necessarily equal to 3 because of the 0 units of demand observed in the 8 weeks, which postponed the order receipt, the next order receipt for 1 week later. So please do not think that whenever you apply this periodic order quantity interval, that does not mean you will always be planning a receipt at every following 3 weeks. I mean, it is not sensible, right? I mean, if you have 0 net requirement here, why should you consider receiving any inventory, right? So in this plan, again, there is this part. We know the supply lead time is 1 week. Therefore, the planned order receipts, in order to get this planned order receipts, we need to release the regarding orders 1 week earlier. We will be receiving 3 separate orders, my friends, here, which will cost us a total of $300. For each order release, we pay a fixed ordering cost of $100. And starting from the 2nd week to the 11th week here, the amount that is carried from one period to the next as a sum of this row. Remember, we are excluding this 35 again because this is already carried from previous planning horizon. We are only summing up the carried inventory amounts or the on-hand inventory amounts in the remaining columns, which sum up to 195. And each unit that is carried from 1 week to the next costs $1 in this problem. So the total inventory cost associated with the lot sizing heuristic based on the periodic order quantity is 495 compared to the 2 previous heuristic methods. This is a lot better. But I mean, it is possible to calculate much better plans based on some advanced heuristics, which we are going to cover in the following videos. So in the next video, we are going to cover the most famous heuristic of all about lot sizing problem, which is the silver meal heuristic.